You have a dead motherboard on the bench. You plug in the adapter, check the main power rail, and measure a healthy 19 volts. Probing further reveals that the initial step-down converters are functioning correctly, successfully generating the 3.3-volt and 5-volt standby rails. But when you press the power button, there is no response. The board appears dead, even though primary and standby power are present. At this point, many technicians make a critical error. They immediately reflow the CPU, replace the platform controller hub, or flash the BIOS without testing. These invasive actions waste labor and can damage a repairable board. They focus on the end of the power sequence, when the failure is occurring much earlier in the logic chain. An unresponsive power button combined with active standby rails indicates a breakdown in the S5 standby logic sequence rather than a failure of the primary processing chips. This is the LA9104P motherboard used in the Dell Inspiron 3521. We must identify 3 specific components before the power button is pressed. In the bottom left is the embedded controller, or EC. At this stage, it is the active monitor responsible for checking all standby conditions. Near the memory slot is the platform controller hub, or PCH. Currently, it is held in a reset state. The CPU at the top center is unpowered and has no role in this initial phase of the startup sequence. A specific signal sits between the EC and the PCH. This is resume reset, or RSMRST hash, which provides the signal required for the PCH to exit its standby reset mode. Until the EC successfully asserts the RSMRST hash signal, the PCH remains in reset. It cannot acknowledge or respond to the power button. We can trace the chronological power sequence starting with the 19-volt adapter input at the DC jack. This 19-volt supply is stepped down to generate the 3-val ALW and 5-val ALW standby rails. The 3-val ALW rail specifically powers the KB9012 embedded controller. Once the EC is powered, it runs an internal checklist to verify that these standby power rails are stable. The EC also monitors the real-time clock circuit, which must be valid for the sequence to continue. Reaching this stage confirms the management chip is functional, but the system cannot move toward a boot state without a successful handshake with the PCH. When the standby conditions are met, the embedded controller triggers the RSMRST hashtag signal. This stands for resume reset. The hashtag symbol denotes an active low logic state. To release the PCH from its reset state, this signal line must transition from a logic low of 0 volts to a logic high of 3.3 volts. At this point in the sequence, the BIOS and CPU are not involved. This is a direct point-to-point communication between the EC and the PCH. This voltage change signals the PCH to exit the S5 reset state. It is now ready to monitor the power button pin for user input. This RSMRST hash transition is the requirement that separates a powered standby board from an active computing system. Once RSMRST hash is high and the power button is pressed, a rapid chain reaction begins. The PCH responds by generating sleep signals like SLP_S5 hash and SLP_S3 hash, activating secondary power rails. The chain continues to the platform reset signal, PLT_RST hash, initializing the motherboard logic. The sequence concludes with CPU vCore activation and the software post-process. This entire sequence is impossible if the RSMRST hash signal fails to reach 3.3 volts. Let's apply this logic to the physical workbench using the LA9104P. You can verify the signal by measuring at the PCH side pull-up resistor or at a test point along the routing trace from the EC. On a functional board in the S5 state, with the adapter connected, this line should measure approximately 3.3 volts. A reading of 0 volts confirms the startup sequence has stopped at the EC. This finding eliminates the PCH and CPU as immediate suspects, allowing you to focus troubleshooting on the EC and its prerequisites. If RSMRST hash is missing, check for absent standby voltages or a failure in the RTC circuit. Other causes include corrupted EC firmware or a physical short within the PCH pulling the signal line to ground. Verify the S5 standby sequence with a multimeter before considering the replacement of major BGA components. If you need assistance with power issues or schematic analysis, we have resources available. Need help with motherboard repair? Upload your schematic, board view, or motherboard photos to Aries Schematic AI and ask your repair questions. See the links in the description for more information.